Hello, this is Module 5 in Basket theory, and we're going to talk about the transformation of the polynomial. So transformation means we have several transformations of the function. So let's talk about the some of the transformation first, okay? So let's look at the notes to go back to look at this one. Okay, so the 5.3, okay, which is a transformation. So first transformation, we have a shifting. So when we have a shifting, so first one is a vertical shifting. Or for vertical translation, so that's the same thing. Some books says a translation. So if you have your function is x squared, okay, so vertical shifting means you actually move the graph up and down. So as a g functions, and then you actually move the f of x to plus k units, okay. So if the k is a positive number, then the graph of g function moves k units upward. And if the k is a negative, that means the graph of function f moves k units downward. Okay, so let's get the example here. So let's say your g function is, let's say x squared plus 3. Okay, so on the plane, okay, first of all, we need the graph of f function first. So f function means 0, 0, which is this is the f function, okay? 0, 0, and 1, 1, and 2 to 4, and then negative 1 and 1, and negative 2 to 4. If you square all the number becomes the positive number, right? So these are the f functions. Now, graphing the g functions, okay, which means you are going, since the k is a 3, which is a positive, so going up 3. So all the points, we're going to move up to 3. So from here, 1, 2, 3. From this point, 1, 2, 3. This point, 1, 2, 3. And this point, 1, 2, 3. And then this point is 1, 2, 3. So this is a graph of moves the 3 units up. So which is the g functions. Now, I can have h functions this time. This time I make the x squared minus 4, which means the k is a negative 4, which is less than 0, so down 4, okay? From the f function though. So from the f function, I'll go down 4. So 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. And then 1, 2, 3, and 4, okay? And then this is your graph of the h. Okay, so this we call the shifting as a vertical shifting, okay? All right, let's get to the horizontal shifting. So for the horizontal shifting, and then you will get to the, of course, is the f of x equal to x squared, which is, I'm talking about quadratic functions, okay? So your g of x, let's use a g of x, is going to be the f of x minus h. So if, I can use a black, isn't it? Okay, so let me erase this. Let's use a black. So your g of x is now the f of x minus h. So in here, if h is a positive number, then the graph f moves h units to the right. And if h is less than 0, then the graph of f moves h units to the left. So what does that mean is, okay, so let's say your g function is, you got the x minus 3 squared. So when I say h is always comes with a negative, okay? So you got negative, which means your h is in here is a 3. Your h is a 3, which is a positive. So it goes to the right from the f of x equal to x squared, okay? So if I put in the plane to this, so from the graph of the 0, 0, which is the x squared functions, okay, 2 to the 4, negative 1, 1, and negative 2 to the 4. So this is the parabola of the f functions. So this is f. Now, as a g function, I'm going to move the points from the f function to the 3 units, right? Okay, so move 3. So move here, 1, 2, 3. Move it 1, 2, 3. Move it 1, 2, 3. Move it 1, 2, 3. And move it 1, 2, 3. Everything just to move the right. So this is a g functions. Okay, so this is the g functions. Now, h functions, I want to say the x plus 5 squared, which means the same as this is x minus of negative 5 squared. Okay, which means h is a negative 5. That's why you need to move to the left. So from the f functions, you're going to go to the left. So 5. 1, 2, 3, 4, 5. Move it 1, 2, 3, 4, 5. Move it 1, 2, 3, 4, 5. Move it 1, 2, 3, 4, 5. And then move it 1, 2, 3, 4, 5. And then you get the h functions right here. So this is h functions. Okay, so that's what we call the shifting. And then, of course, we have the stretching and the compressing, but I'm not going to talk about that here. So number 2, I'm going to do the reflection. So we have a 2 reflection. One is the vertical reflection. So when you have a function is x squared, okay, which is g of x will be the negative f of x. That's a vertical, the reflections. So you got the g of x is going to be the negative x squared. So on the plane, okay, so graph of g, which is from the f, okay, so f functions are 0, 0, 1, 1, 2 to 4, negative 1, 1, and negative 2 to 4. So these are the f functions. Oops, what am I doing? Okay, so I need to connect it as a curve, which is right here. Okay, and then, so this is f function. So now what I do is, I'm going to make it upside down. So vertical reflection means that you got a graph that is the rotate by x-axis, okay? So which means you're graphing that as, instead 0 just stays the same though. Instead of the 1, negative 1 and 1, you got negative 1 and negative 1, 1 and negative 1, and then 2 to negative 4, 1, 2, 3, 4, and then negative 4 from the 2, 2. So this is the graph. So this is g functions. And also, we have a horizontal reflection. So horizontal reflection means you have g of x is going to be the f of negative x. So in order to find it, for the g function, it's going to be the, let's put the h function, okay? Because we already use g, so I'm going to use the same graph. So over here, I want to say h, and this one is the the h of x, okay, which means a negative x squared, which is come out as a positive x squared, so it stays the same as x squared, okay? So which means for the vertical reflection, you rotate this, okay? And then for the horizontal reflection, you rotate this way. So which means this one, right, becomes this. And then this one is going to becomes this. So you know what? It's going to be the same, isn't it? So, yeah, it's the same. Alrighty, so let's go back to the 5.3. So 5.3, I will do number 6 to see the graph. So define each function in terms of the order or terms of the other. So express the output of the g in terms of the output of the f. So the f function is, this is f function graph, and then this is a g function subgraph. So they look similar except the direction, isn't it? So I want to say this is a reflections. So I want to say this is image of this one, and then this is image of this one. So dashed line is image of the other way, but it just makes upside down, right? So I want to say the g function is negative f of x. But also, you can also think about it as this is a reflection of this, and then this is a reflection of this one. Because of that, this is actually the horizontal reflection. So you can say also g of x is f of negative x2. Now, express the output of the f in terms of the outputs of the g. Same thing. Now, you're going to find out what is the f of function is. It's going to be the reflection of g of x. Sorry. And then also, as a horizontal, f of x same as g of negative x. So it's the same. All right, now B, express the output of the G in terms of the output of the F. It looks like a translation, which is a shifting, isn't it? So this graph actually move it from this vertex as F to this one, isn't it? So if you see the move means it downs to actually the 7, right? And then it goes right to. So step 2, okay? So that's how they move, right? So the G function, which is moved from the F from the right 2, isn't it? And then the down 7. But if you are looking at the other ways, okay, which is F functions, now it is, right? So now from here, you go to the left 2, right? And then you go up 7, isn't it? So you gotta say G function from the F of the left 2 means what? Negative 2 is a plus 2. And then you go up 7, right? So that's what it is. For the C function, express the output of the G in terms of the output of F, which is, okay, there's some shifting, isn't it? So from the F to the G, so the graph was, the vertex was here to get here, isn't it? So it goes to the how many left? It actually moved to the negative 4, right? And then up to actually the 5, isn't it? Go up to 5, isn't it? So the k is a 5 and the h is actually the negative 4. So g function is, and also upside down, right? So g function is, there's a reflection vertically, and then from the f of, and then you go to the right, and then up to 5. Other ways, f functions, other ways, right? So now from the g function to go to the f function, which is you go to the, let me use another color for this one. That makes it better, okay? So in this case, now from here to here, isn't it? So down 5 and then right 4, isn't it? So you got f function is now from the g function's reflection, but you go right 4 and then down 5. All right, so now which of the function part A through the C could be the polynomial? So being a polynomial function graph has to be the smooth and then continuous, okay? And then nice curvy, okay? So which is A and C are the polynomial. The B is not polynomial. This is actually the absolute value function. So, whatever number you use, it always become positive. All right. Thank you for listening.